Alright, welcome to Unit 3, Lesson 3. Got one more thing to do with perfect competition, and that's to look at what happens over the long run. So far we've been looking exclusively at the short run, in which firms choose their output to maximize profits or to minimize losses. And we've said that even if a firm is losing money, in the short run they might stay in the industry because they're better off staying in and losing less than their fixed cost than they would be shutting down and losing their entire fixed cost. Well, in the long run, remember, we've already talked about with costs in the long run, there are no fixed costs. Firms can sell off the land that they've purchased or rented, or they can sell the capital equipment they've purchased or rented. They can exit the industry, essentially, if they're losing money in the long run. And that's what they would do. If they're not going to continually lose money when they can get out of that industry. So we're going to analyze what happens over the long run using a kind of new way of looking at this on graphs. And we're also going to analyze like the reverse situation, which is when firms are making profits, then what happens over the long run to bring the industry into kind of an equilibrium. Okay, so what we have on the slides here is kind of a setup here. These 4 bullet points. There's free entry and exit. One of the conditions of a perfectly competitive market is that it's fairly easy to get in and out of the industry. We talked about this in terms of the tomato farmers or the corn farmers or orange farmers or whatever. It's fairly easy to set up your own farm, and if you need to get out of the industry, it's fairly easy to sell it. There aren't big costs or barriers to entry associated with these markets. And so, second bullet, repeating what I already said, if a firm is losing money but producing in the short run, in the long run, eventually it will sell its fixed inputs and exit. And on the flip side, if firms in the industry are making profits, then this probably will attract other people to say, hey, maybe I would like to be in that industry making profits as well. And they will enter the industry. So we'll look at both situations and where the market ends up in the long run. So here's the new graph setup that to introduce for this piece. We'll call them side-by-side perfect competition graphs. What this is an illustration of how firms in a perfect competition take the market price and make that as their demand curve or their marginal revenue or their average revenue. On the right-hand side, the right-hand graph is the graph of the firm, which we've seen before, and that's why we have the perfectly elastic, horizontal, marginal revenue curve. On the left-hand side, I'm going to call this the entire market. So if we're talking about tomato farmers, this would be the whole market for all tomato farmers selling their product, and it has both supply and demand. It's just a standard supply and demand graph. We're going to call that the entire market graph. In a market, the equilibrium of supply and demand determines the market price. And that price, that's why this dotted line connects over, that is the price that the firms take. So if this is, the numbers we used before, if this is $18 per unit of tomatoes, then that's where the $18 comes from that the firms take. It's that equilibrium of supply and demand. So once the firms take that market price, then depending on their costs, we've seen how they might make profits or losses. And as we move now to the next slide, what we've got is a picture of, using the side-by-side graphs again, a picture of a firm making profits as a result of the market price being one that's profitable to them. Let's use it again, 18. It's the one in this example we keep using. And we saw before that a firm, this tomato firm with a price of 18 is going to be making profits. We can note that on here because the price is above the average total cost of production. Here's the profit maximizing quantity. And here's their area of profits. So just recognizing that's a graph of a perfectly competitive firm making profits. Okay, so that can continue in the short run. Firms can make profits during the short run, and these would be economic profits, in fact. I'll bring in this economic versus accounting profits back into it. We're going to assume that all these cost curves include implicit costs now. We haven't specifically said that, but now that we're doing this analysis with perfect competition, for this to make sense, these cost curves need to include implicit costs. Therefore, if firms are making profits, they're not just accounting profits, they're economic profits. They're making more than it takes to keep them in this industry and keep them from switching to another one. Okay, so again, that can keep going for the short run, but in the long run, we're going to assume that if there's a bunch of tomato farmers making economic profits, making more money than they can make at the next best thing, there are still some people doing those other things, the next best thing to tomato farming. And it's likely that eventually, over the long run, they're going to look at what the tomato farmers are doing and notice that there's profits to be made in that industry. And if there's free entry and it's not too hard to start your own tomato farm, they'll think, well, maybe I should start my own tomato farm. And they will. And that's where number one comes in. In the long run, new firms will enter this industry. More people will become tomato farmers if there are profits being made in this industry. And the result of that, now it's two, is an increase in the market supply in our graph on the left-hand side. So we know that an increase in supply on a supply and demand graph looks like this. And an increase in supply decreases the market price down to whatever this would be, P2. Firms should continue to enter the industry until the price falls all the way down to where there's no longer profits being made. So I'm going to erase those profits. And we actually know from these examples from the previous videos what that price is. Remember, the break-even price was 14. So we can predict if this is the structure, using the numbers that we have in those previous examples, that once the price fell, once enough firms had entered for the price to fall to 14, now firms are taking a market price of 14, breaking even, and now there's no more incentive for new firms to enter the industry. And now that process stops. Let's do one more thing here. Let's label this P2 equals MR2. We're labeling a new price marginal revenue curve. And then for each individual firm in the industry, the quantity they produce decreases, even though the market quantity, the whole market quantity, increases. It's because there's now more firms in the industry. Each of them individually is producing less than they were before, just a little bit less. But overall, the market supply and market quantity has increased. Okay, so there's the long-run adjustment process when firms are making profits. You need to get to know this sequence real well. New firms enter, supply increases, which decreases price, until it reaches that long-run equilibrium price, the break-even point. Next, let's go to the opposite example. If firms are losing money. We've got our side-by-side graphs. We know from our previous example that at $10, firms were losing money, so let's call that 10. This firm is going to be producing this quantity and losing this amount of money. So in the short run, let's assume they're going to continue to produce because that's still prices above their average variable cost, their minimum average variable cost. But over the long run, these firms, or at least some of these firms, are going to exit the industry. And as they do that, now the reverse of what we saw before, the market supply decreases. A decrease in supply looks like that, which increases the market price. So as some firms get out of the industry, the situation actually becomes better for the firms that stay in, the existing firms, because the market price rises for them. So if the price rises to 14, again, we'll connect that over. Here's our new P2 equals MR2 at 14. And again, we're at that break-even price. The individual firms now produce more, even though the total market is producing less, because at higher prices, we move along the demand curve and some less consumers are going to buy it. But again, then it goes to that equilibrium point. There's no longer pressure for firms to exit once they're breaking even in terms of economic profits. So that again is long-run equilibrium. The result of all this is that the long-run equilibrium, we can always say for perfectly competitive markets, is where firms break even in terms of economic profits. And that's actually, there's a phrase for that. That's called a normal profit firms are making normal profits when they're breaking even in terms of economic profits. And we know what the graph of that looks like too. If we said, draw a graph of a firm that's in long-run equilibrium in perfect competition, we should know that all we have to do is draw first the marginal revenue curve, the marginal cost curve, and the average total cost curve. And if it's in long-run equilibrium, that's the break-even point, which, as we saw in the previous lesson, or maybe 2 lessons ago, is where the ATC is tangent to this MC equals MR point. There's no area of profits on here. That's a firm breaking even. That's a firm in long-run equilibrium in perfect competition. Okay, that's the process. The AP exam loves this process, loves to ask you to graph it and explain it, so we'll look at a bunch of examples about that, and we'll see you in class.